Good day, students and parents! You are watching Valenzuela Facebook Live. Today, we are on our Quarter 4, Week 3 module, and we will be discussing about the frequency distribution table. Our learning competency for this lesson is to organize data in a frequency distribution table. To start, let me ask you this question. Are you familiar with the game Mobile Legends? Let us say that in an interview of 15 gamers, these are their responses when asked, who is your main hero in Mobile Legends? Their answers are Chang'e, Benedetta, Chu, Benedetta, Angela, Chu, Louie, Benedetta, Kufra, Chu, Angela, Brody, Angela, Atlas, and Benedetta. Based on the gathered data, who is the most chosen hero? Here is a table showing a tally of how many times each hero was chosen. If you think that the most chosen hero is Angela, react like. If you think that it's Benedetta, react wow. If you think it's Chu, react haha. And if you think that it's Kufra, react heart. You have 5 seconds to send your reactions. Time's up. The correct reaction is, wow, Benedetta is the most chosen hero. What we did earlier is an example of a frequency distribution table. Then, we can define a frequency distribution table as a table that presents the values listed in a dataset and its frequency. But, what if we have a very large number of responses? We can't just enumerate them all in a table. That is why we have what we call a grouped frequency distribution table, wherein the values and frequencies were grouped, especially for large or varied datasets. Do you know how to make a frequency distribution table? We will do this step by step, so listen very carefully. Let us take a look at this example. Ma'am Dayan wants to know if the amount of time spent by her students in studying mathematics is related to the grades they got for a specific quarter. She interviewed some of her grade 7 students and their answers are shown here. It is a list of the number of hours spent in studying mathematics per week by Ma'am Dayan's students. From here, we are expected to find answers to the following questions. First, how many students responded to the survey? And second, how many of them study mathematics weekly for at most 2 hours, 4 hours, 6 hours, 8 hours, 10 hours, and 12 hours. These responses from the students that we collected is what we refer to as raw data. It is the initial data gathered for a study. This data still needs to be organized in order to produce a meaningful information. So, to prepare a frequency distribution table for this data, we simply write the number of hours on the first column, starting from the lowest, which is 1, to the highest, which is 12. Then, we have tally on the second column and frequency on the third column. For the tally, we are going to put 1 tick every time each number occurs on the raw data, starting with 1. Every time we see 1 on the raw data, we put a stick on 1 on the tally column. There is only 1, so we have 1 stick. Then, we go to 2. We have 2 2s on the raw data, so we have 2 sticks. 2 sticks for 3. 4 sticks for 4, 2 sticks for 5, 5 sticks for 6, 1 stick for 7, 1 stick for 8, 2 sticks for 9, 2 sticks for 10, 2 sticks for 11, and finally, 1 stick for 12. After we complete the tally column, we proceed to the frequency column. To complete this part, all we have to do is to count the number of sticks on the tally part and write in figures, just like this. Frequency refers to how often something occurs. Therefore, for the frequencies, we have 1, 2, 2, 4, 2, 5, 1, 1, 2, 2, 2, and 1. N represents the total number of raw data that we collected and is equal to the sum of the frequencies. Therefore, N equals 25. And that is how we make a frequency distribution table. Simple, right? But how does it differ from a group frequency distribution table? I want you to take note of the steps on how we are going to make this one so that you will be able to remember them. Taking note of the examples that we will have will be of great help too. Are you ready? So, here are the steps in constructing a group frequency distribution table. Step 1 is to determine the range, which is represented by R. Step 2, calculate the group size, represented by small letter s. Step 3, identify the start value. Step 4, compute for the list of groups. Step 5, write the frequencies and total. And step 6, find the class boundaries. Let us follow the steps one by one, and together, let us construct the group frequency table using the raw data we used a while ago. Step 1 is to determine the range R. Again, we will be using the same data we used earlier. Take note that the range is the difference between the highest and the lowest value. So from our data, our highest value is 12 and the lowest value is 1. Then, we have the formula for range, which is R equals HV minus LV. Substituting, we will have R equals 12 as the highest value minus 1 as the lowest value. Subtracting 12 minus 1, we obtain R equals 11. Get it? Good. Then, after getting the value of R, step 2 is to calculate the group size S. To calculate for the group size, we will be needing the value of the range, which we computed earlier, which is equal to 11. Also, we need to decide on the number of groups or classes C. Suppose we want to have C equals 6 groups or classes. Take note that the one conducting the research is the one deciding for the number of groups or classes. But in our case, the teachers will provide the number of groups or classes so that students will have uniform answers. Going back, since it's given that we will have 6 groups, next thing to do is to divide the range by the number of groups. Our computed range earlier is 11, and the number of groups is 6. So, dividing them, we will have S equals 11 divided by 6. Then, S equals a non-terminating decimal 1.83. In this case, we will round up to get a whole number. Therefore, S is approximately 2. Next step is to identify the start value. We have computed the range, which is 11, and the class size S, which is 2. Now, we need to identify the start value. More often, we use the lowest value as the start value. Since the lowest value is 1, we use 1 as the start value. Can you follow? Listen more carefully. Focus and as much as possible, take notes. Now, we are on step 4, where we will now compute for the list of groups. Remember what we did from steps 1 to 3. We came up with a range equal to 11, group size 2, and start value equal to 1. Now, using the start value 1, we will compute for the list of groups. First, write 1 as the starting value. Then, we will use the class size to know up to which number the first group will be. The class size tells us how many scores fall within each group. Since we computed the class size as 2, that means that for each group, there should be 2 scores. If we start with a score 1, the first group will be 1 to 2. That's 2 scores, right? Scores that are 1 and scores that are 2. Then, we do the same for the second group. We have 3 to 4, that's 2 scores, and 5 to 6, 7 to 8, 9 to 10, and 11 to 12. We can now stop at 12 since it's already the highest score. Also, it says from the given data that we only have 6 groups. And if we count the number of groups that we have 1, 2, 3, 4, 5, 6 groups already. Good job, guys! These groups that we have formed are classified into 2. The lower limits, which can be computed by adding the group size 2 and the lower limit of the previous group. So, we will have 1 plus 2 equals 3. So, we write 3 as the lower limit of the next group. Then, 3 plus 2 equals 5. So, we write 5 on the next group. Then, adding 2 repeatedly, we will have 7, 9, and 11. Then, these are our lower limits. The other classification is what we call the upper limits. To get the upper limits, we subtract 1 from the lower limit of the next group. So, to get the upper limit of the first group, we have 3 minus 1. So, we write 2. Then, 5 minus 1, we write 4 as the upper limit of the second group. Repeating the steps, we will get 6, 8, 10, and 12. And these are our upper limits. These lower limits and upper limits gives us the 6 groups that we will use for the next step. Here, in step 5, we will write the frequencies and total. We need the raw data and the table that we prepared containing the 6 groups we computed. Now, how are we going to do that? First, refer to the given data sets. Then, we will determine the frequency of all the values housed in each group or class. We can count them from the list or use a scratch paper in making a tally. Like for example, on the first group 1 to 2, its frequency refers to how many from the data falls within 1 to 2. There is 1 who answered 1 and 2 who answered 2. Then, all in all, the frequency of scores that fall within group 1 to 2 is 3. Next, how many answered 3 to 4? These are the ones who answers falls within 3 to 4. Then, its frequency is 6. For group 5 to 6, the frequency is 7. For group 7 to 8, the frequency is 2. For group 9 to 10, the frequency is 4. And for group 11 to 12, the frequency is 3. Now that we completed the frequencies, we will get the total of the frequencies which is represented by n. So adding all the frequencies gives us n equals 25. Finally, for the last step, step 6, we will find the class boundaries. Given the group frequency table that we made, how can we find the class boundaries? Class boundaries are used to separate the classes so that there are no gaps in the frequency distribution. What do we mean by these gaps? For example, between the first and second group, 1 to 2 and 2 to 3. There are still numbers between 2 and 3, like 2.1, 2.2, and so on. So we are going to make sure that there are no gaps between groups using class boundaries. It's just simple. All we have to do is to subtract 0.5 from the lower limit to get its lower class boundary. Refer to the lower limits and subtract 0.5 to each lower limit. We will get 1 minus 0.5 is 0.5. Next, we will add 0.5 to the upper limit to get the upper class boundary. So, adding 0.5, we will get 2 plus 0.5 will be 2.5. Repeating the process, we will get 3 minus 0.5 is 2.5. 4 plus 0.5 is 4.5. 5 minus 0.5 is 4.5. 6 plus 0.5 is 6.5. 6.5 to 8.5. 8.5 to 10.5. And 10.5 to 12.5. So that completes our class boundaries. Now, we are done constructing our group frequency distribution table. Have you taken note of the steps? I hope you did. But for you to get more familiar with the steps, of course, the secret is to keep practicing. So, are you ready with another example? Let us do this together. The following are the measures of weight of grade 7 students in pounds. Construct a group frequency distribution of 6 classes for the given data. So, here's the data that we are going to use. We need to answer the following questions. First, how many students belong to the group with the lowest weight measurement? Second, what is the range of weights that is most common among the grade 7 students? And third, is there a weight group that has a zero frequency? What does it imply? Let us now start constructing a group frequency distribution table using this data. Again, we start with finding the range. Do you still remember how to compute for the range? Very good. R equals HV minus LV. So we look for the highest value and the lowest value from the data. The lowest value is 66. And the highest value is 128. Then, R equals 128 minus 66. Then, R equals 62. After the range, we compute for S, or the group size. That will be R divided by the number of classes. Since R equals 62 and the number of classes given is 6, then we have 62 divided by 6. Therefore, S equals 10.333 repeating, and rounding up to the next whole number, then S will be approximately 11. Then, we proceed to determining the start value. The start value can be the lowest score, so we write 66 as the start value. Take note that we can write the groups in increasing or decreasing order. So, There will be times that the groups will be written from bottom of the table going up, or like this one, from upper row going down. We will now find the group's lower limits and upper limits, starting with 66. Since the group size is 11, that means that there should be 11 scores included per group. So we start counting from the scores 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76. Now, we have 11 scores for the first group, which is from 66 to 76. For the second group, we start at 77 and count 11. So we have 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87. That will be our second group from 77 to 87. Then, we do the same for the third group, starting from 88, count 11. Then we have 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98. Then our third group is from 88 to 98. We just repeat the process and count 11 until we form 6 groups. So for the fourth group, we have 99 to 109. Fifth group will be 110 to 120. And finally, for the sixth group, we have from 121 to 131. Now that we have 6 groups, we can now proceed to counting the frequencies for each group. Let us count. How many scores fall from 66 to 76? 1, 2, 3, 4. Then, we write 4. For 77 to 87, we have 8. For 88 to 98, we have 12. 99 to 109, we have 9. 110 to 120, 0. And for 121 to 131, we have 2. We have N equals the total frequency, so N equals 35. Now that our group frequency distribution table is complete, let us start answering the questions. For the first question, how many students belong to the group with the lowest weight measurement? Based from the frequency table, there are 4 students who have weights from 66 pounds to 76 pounds, which is the lowest weight group among the grade 7 students. For question number 2, what is the range of weights that is most common among the grade 7 students? From the table, we can say which is the most common by looking at the group with the highest frequency. Therefore, 88 to 98 pounds is the most common weights of the grade 7 students. For question number 3, is there a weight group that has a 0 frequency? What does it imply? As we can see on the table, yes, there is a weight group that has a 0 frequency, that is 110 to 120 pounds. A 0 frequency implies that there is no score or data that falls within that given range. Well done, guys! Looks like you somehow get to use with the steps in constructing a group frequency distribution table. Let us try to check how much you understand about this lesson by answering the following practice questions. For this exercise, we are going to use this data showing the ages of Valenzuelanos who got vaccinated for a day in one station. So, this will be the data that we will be using. You may type your answers on the comment box. Let us start with question number 1. What is the range of the given data? You have 5 seconds. Time's up. Range is obtained by subtracting the highest value and the lowest value. So we have 76 minus 18. Therefore, the range is 58. Did you get it correctly? I'm sure you did. For question number 2, if we will be using 5 groups or classes, what will be the group size S? You have 5 seconds. Time's up. Since S is equal to range divided by the number of groups, we will have 58 divided by 5. S will be equal to 11.6. Round up to the nearest whole number, we get S is approximately 12. You're doing great, guys. For question number 3, if we are going to construct a group frequency distribution of data, what will be our starting value? 5 seconds. Time's up. Correct. Since the starting value will be the lowest value, then the starting value will be 18. Question number 4. If 18 is the starting value, what number should be added to 18 to obtain the preceding lower limits? Complete all lower limits. You have 10 seconds. Okay, time's up. The number that we are going to add to obtain the preceding or the next lower limit is the class size or S. Therefore, we are going to add 12. Have you completed all the lower limits? Let us see if you got them correctly. By adding 12, we will obtain 30 plus 12 is 42. Then, plus 12 is 54. And plus 12 is 66. So, these are our lower limits. Question number 5. How will you get the first upper limit and the succeeding upper limits? Can you list them all? You have 10 seconds. Time's up. To obtain the first upper limit, we subtract 1 from the lower limit of the next group. So that will be 30 minus 1 is 29. Then, to obtain the succeeding upper limit, we add 12 from 29. So that will be 41. Then, 41 plus 12 is 53. 53 plus 12 is 65. And 65 plus 12 is 77. So, that completes our 5 class limits or the 5 groups. Now, for question number 6, based from the given data, complete the group frequency distribution table by giving the frequencies for each class or group. 10 seconds. Time's up. Let us see if you counted them correctly. For 18 to 29, we have 8. 30 to 41, we have 7. 42 to 53, we have 9. 54 to 65, we have 4. And for 66 to 77, we have 2. Which gives us n equal to 30. Good job, guys! Now, for question number 7, according to the group frequency distribution table, which age group has the most number of bakunadong Valenzuelanos? 5 seconds. Time's up. Again, look for the group with the highest frequency. Therefore, mostly of the bakunadong Valenzuelanos in this table are those with ages from 42 to 53. Question number 8. According to the group frequency distribution table, which age group has the least number of bakunadong Valenzuelanos? 5 seconds. Time's up. Now, we are finding the list. So, look for the group with the lowest frequency. Therefore, 66 to 77 is the age group that has the least number of bakunadong Valenzuelanos. Congratulations, guys! That was amazing for a practice. Let us have the second set. Now, given this group frequency distribution table, what is the total number of scores or data being treated? We are looking for N. You have 5 seconds. Time's up. All you have to do is to add all the frequencies. Then, N equals 40. Next one, in the group frequency distribution table shown, how do we compute for the class boundaries? You have 5 seconds. Time's up. To compute for the class boundaries, we just subtract 0.5 to each lower limit and add 0.5 to each upper limit. That will give us 4.5 to 9.5, 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5, and 24.5 to 29.5. That would be all for our practice questions. I hope that you are now familiar with the steps in constructing a group frequency distribution table. If not, remember that the secret is to keep practicing. Before we end this session, let me leave you this thought to ponder. Everything in life has a frequency, and whatever you are feeling is bringing everything into your life that is on a similar frequency to you. Again, this is Ma'am Christine G. Noriega for Valenzuela Facebook Live, and I hope that we all have a great day ahead. Have a nice day!